Though we know who we are, yet we know not what we may be. So maybe I'm the one, or maybe I'm crazy. I'm from.
Welcome back to your Malarkey Guide to Machine Learning. My name is Kalu, and as we said in the last video, we have some assumptions that must be true in order to, for multiple linear regression, in order to figure out what linear model best fits our data. So one of those assumptions is we must have a linear distribution. What does this mean? So we started off right where we left off in the last video, so you guys should still have all this open up in your terminal. If you don't, you can watch my last video. So what this means is we need to make sure that all of our variables have a normal distribution, or all of our independent and dependent variables have a normal distribution. So in order to look at the distribution, we can use SNS, this thing that we imported with import Seaborn as SNS. We did it in the last video, so you guys should still have that. So now that we have this, why don't we go SNS.regplot, and let's just look at the dependent variable, which we called our Y, or we can also call it price. Oh, sorry. Distribution plot. So we want to look at the distribution plot. So SNS.distplot, and then do plt.show. And again, PLT should already be imported. And this is the distribution right here. What we want is a Gaussian distribution or normal distribution, something that looks more like a bell. Ours doesn't look quite like a bell. We want it to be more over here. So this is an issue that we're going to run up that's going to affect the accuracy of our model. But it looks kind of normal. It could be more normal. And in fact, in the future, we're going to talk about data transformations or data pre-processing, doing things that can make our data more fit the assumptions that we need to be true in order to do multiple linear regression. So for instance, we could do log transform. And I'm just showing you guys what that looks like. Log transform just means multiply. Instead of using the actual figures, the actual observed sales price for all 1,460 observed data that we have, instead we can take their log. So NumPy has something called log 1p, and we can instead just plot, instead of the price, let's use NumPy to just plot the log of it, the natural log, and price. And then why don't we show that graph again, and we can see this looks much more like a normal distribution. And if we go ahead and do this for our independent variables, both the garage area and then just the above ground area, we'll see that our distribution is also not quite a normal distribution. It is normal-like, but it's a bit skewed. So we want to fix the skewedness of all of our distributions, of all of our variables that we use. But for now, we're just going to use the regular prices and then see how this affects our models in the future. We're not going to take the log of it. We're just going to use the regular prices and regular variable as is. And then in the future videos, we're going to talk more about this log transformation. But I just want to let you guys know that you would want to do a bit more processing to make sure that your data do meet some of the assumptions about necessary in order to use the linear regression model. So with that being said, why don't we go ahead and look at the first thing we need, the formula. So if you go to this website, it gives you the formula for linear regression, and this is just y equals a plus b1x plus b1 times x1 plus b2 times x2. So y here is the predicted value of y, which is what we predict our grandma's house to be. A is the y-intercept, B, which is what a house would be if all of these are 0. So B1 is the change in y for each one increment in x. This is just the coefficient. We'll talk more about what a coefficient means. It means for every increase, we'll talk more about what the coefficient means. But this is the coefficient for independent variable 1, and this is the coefficient for independent variable 2, and x is the actual observed data that we're going to use to make our prediction. If you don't understand what all this means, don't worry, because if you've been following the Kalu principles of learning a new discipline, you know that we believe in a bottom-up process of learning, not top-down. We believe in inductive reasoning, not deductive reasoning, and we definitely believe in learning by example and not learning by memorizing a whole bunch of rules. So if you don't understand what all these concepts means, we're going to learn by example. We're going to go through it, and then you can go back and watch this video, do an iterative process. Go back and watch this video to see if you now better understand what these things mean. So if you don't understand this now, that's okay. That's why you're here. You're here to learn. In the future, you're going to understand this more. But why don't we implement some of this formula? So first thing, we need to calculate the B1, the coefficient for the first independent variable. So how do you calculate the B1, B sub 1, B sub 2? So to calculate that, this is a formula we use. And what does all this means? Thankfully, we have this legend to tell us. It tells us that we need to calculate the correlation between y and x1. So our x1, if you guys remember, is x1.describe, x1.describe, and I forgot to call it. Our x1 is our area, and then our x2 is our garage area. So x1 is our general ground living area, and then our x2 is our garage area. We're going to use these two predictors, these two independent variables, to use to try to map what that is, the relationship between these two variables are with our actual sales price, our dependent variable. So we're going to first, in order for this variable, we're going to need to get the correlation between garage or ground living area, our x1, and sales price, our y. And then we're going to subtract that between the correlation between this, our sales price, and our garage living area times our garage area and ground area correlations. So we're going to need a whole bunch of correlations. So the question is, how do we calculate a correlation? This gives us the nice little equation for calculating a correlation. So you can see we just need to get the sum. This here just means sum. Sum of each of these observed data. We're going to take the observed data and subtract it with the average independent variable. So maybe if our x is living area, for each observed observation, our data, we're going to take that observed data, we're going to subtract it by the average ground area, which we know is area dot mean, which we know is 1,515, and then we're going to multiply that by the corresponding y, the corresponding price for that data set, minus the average price. And then we're going to divide that by the standard deviation of x and the standard deviation of y. That is a lot, but don't worry, we're going to go through this step by step. I promise it's going to be very clear in a minute. So I think what we really need is to find the standard deviation first. So just to make it all clear, what we want to do is use this formula to find what model, what linear regression model best fits the relationship between garage area and ground living area in price, so that we can help predict our grandma's house, what price it should be if we know what her ground living area and garage area. So in order to do this, we need to use this formula. In order to use this formula, we need to first find out the coefficients. So the first coefficient uses this formula. In order to find this out, we need to find some correlations. So in order to find a correlation, we need to use this formula, and then in order to use this formula, we need to find the standard deviation. So the first thing we're going to do is find the standard deviation, and this is the formula for standard deviation. So we're going to tackle all of these in the next video. Thank you guys for paying attention. Don't think too much of it. It's not going to be that hard. I'm just setting up some context and background. We're going to blast through all of this. It's going to be real simple, I promise you. So thank you for watching this video. If you enjoyed this content, don't forget to like and subscribe, or tell at least 10 or 50 of your friends. If you're an African, you got to tell at least 200 or 500 of your friends. So thank you again for watching. Appreciate your time. We're going to have a lot of fun in the next videos actually implementing these formulas in Python. See you guys in the next video. Peace.
Financial freedom, my only hope.